What's coming off around here?
If you guys playing railroad anymore today, there's a landslide, a new cut.
At the end of episode 20, I introduced this host shield, and the next step of my plan is to establish control of my DCC locomotive using the JMRI over a Bluetooth channel. I've introduced this Bluetooth configuration in a previous episode, and I've also discussed how I had a receive and a send Arduino setups for this experiment. And I had stated that I would use the Bluetooth Shield in order to be able to communicate with between the two Arduinos. And in all of that, in this final part of the project, I want to explain how I use the host shield to complete the connection from my damaged laptop to the NCE Power Cab. That goes back, I guess I don't know that I need to re-explain all that. If you're unfamiliar with what I'm talking about, you probably haven't watched the previous episodes going through this process. So, it would just behoove you then to just go back and quickly scan through those just so you can understand what exactly is entailed in having a communication link between the PC that has no USB ports on it and no serial ports for that matter, and be able to use the JMRI software on it, which requires a COM port. So that whole puzzle is being solved ultimately by this final piece right here. I had to study how the host shield can be used for the simple serial COM connection between the two Arduinos. And so I had to read through an enormous amount of information, and I decided at this point to perform some simple experiments in order to build up the required software for this guy. Initially, the thing that I had discovered was that in order to use the shield, well, of course it has to be mounted over here. And oh, by the way, it's talking about this mounting process. Let me just show that these pins are fairly long, and so as you see here on this pin, some of them can get a little bit skewed out of position. So mounting it onto the Arduino Uno is a little bit of a cautious activity. You have to just be careful that the pins are aligned before you try to push them in. Otherwise, they're going to be bent or displaced. The SPI serial interface, which is how the micro on the Arduino Uno communicates with that tiny chip in the middle, which happens to be the host. That's a USB host control chip right there. A lot of stuff going on in that tiny chip. So I'm going to put it together, and then I'll show some initial software experiments that I'm performing just to understand better how the communication process is going to work. So in order to get the host shield to function with the Arduino Uno, I have to mount it, and it's something of a challenge because these pins are quite long and their alignment is not exactly perfect. So let's see if I can first, and by the way, the manner in which the host shield is installed is all the way to the rear, so that the host shield's Type A USB connector is kind of recessed from the other USB connector. And so I've got that one started a little bit anyway. Let's see if I can switch over now and get these to go in. Take that. See, they're slightly canted right now, so I have to tease that in. Oh, easy. Don't want to bend them. If I could just get them started. Oh, great. Oh, man, did I ever hit that one. Come on. Let's see what we got to do here is do was the line? Oh yeah, I did. I really bent that one down. Let's get it back where it belongs. See if I can just get it started. Yeah, fun with HO scale stuff, and this is not precisely the fun that I had intended. Trying to get pins in. Come on. Maybe. Ooh, no. I can't see it that. One more try here. I can see these are pointing out too far. So if I just keep teasing them, you go back. There. Come on. Oh, it's just hanging up. Right there. I think anyone who watches this is going to have to run right out and buy one of these so they can have this kind of fun with HO scale stuff as well. Come on, get in there. I'm getting there. It's just not quite there. Glorious day. There we go. So, and check, make sure none are kind of pushed out or anything. Okay, well that's got it. Let's just push it down. There. And that's pretty much it. That's assembly. Yeah, it won't go in any farther. Okay, so assembly is complete. Thank you for sharing the joy of that. Holy cow. Yeah. So the next thing I want to do is test it out. So I'm going to explain, the information that I had to go through in order to understand how this thing works. Part of it is this chip right here. That is the actual USB host chip, and it does all the heavy lifting on this shield, this board. And so essentially the important part in the short run that I've discovered is that this chip can detect when a device is attached to the USB-A connector. And how it does that is it's part of the USB standard where any device, anything that gets plugged into it, for instance, we have here a USB device. It's a PlayStation 5 controller. I was going to say PS5, but I think people understand PlayStation better. And so when I plug it in, it should detect it, because what the device does is it holds both of the there's two communication lines that go into each one of the USB, that goes into any USB connection. That is the communication lines, and they call them D plus and D minus. And the device will always hold one of those two lines to be in a position opposite of the other. So while this one, the host, is pulling both of those lines low, and so when the device plugs in, the host notices, well, let's say this chip notices that a device is attached because the two lines now are different. See that? And as soon as they're different, and they can be different in one or two ways. Like it could be the D plus is high and the D minus is low, or it can be the opposite. But they have to be different for this device to be able to detect them. And that is going to be the discussion that we're leading to, is can that detect it? So it is also important to point out at this stage that, pardon me, the Arduino Uno has what's called the Host Shield software on there. It's a library available from the Arduino website. And this library already has the coded ability to use the SPI serial interface, or let's see if I can spot it on here. I think it's over here. So the SPI interface, which is, it's over here. It's 10, 11, 12, and 13 of a pins that are going into here. And the SPI interface then can read the registers inside this chip. And so there's a particular register in this chip that has the status of whether the chip sees a device and whether it doesn't. And in which way does it see it, whether it's D plus high, D minus low, or D plus low and D minus high. So let's go on further and see if we can get a device recognized. So the first thing I want to do is I want to hook all of this up and program the Arduino Uno down the bottom there. So I'm going to initially connect power. So that's just power. It's actually on right now. It's got a wall wart plugged in right there that's supplying the power to the Arduino. And then the second thing I want to do is hook up the USB, so I have a COM port for the Arduino IDE to be able to program this thing. So at this point in this attempt to check out the USB host shield, I've got the host shield powered, currently mounted onto the Arduino Uno, and they're connected to this PC. So the PC right now, what you're looking at is an example, but let me show you how I got there from start. First, I had to load the USB host shield library, which that was done by first finding it online and downloading the zip file to my PC. And then I went to Sketch and let's see, I went to include library, and then I used add zip library. And what that does is it comes up with a file dialog that allows you to navigate to the zip file and then just include that zip file. So the host shield library is installed. And then I went from a blank Arduino IDE, no code, to the examples. And then because the host shield library is installed, I can now go down here and choose the PS4 library example. And so the example, once you choose it, it'll load it right up. Well, it's already loaded, so I don't need to do that. So a little bit about that is within the library itself, there are a number of include files that have to be included in order to use it. But in the example, the author of this example just created one library include file for what they call PS4 USB, and that includes everything except for the SPI, which is included here as SPI.h. And the SPI is another set of library routines that are available. So that'll allow us to communicate with the device. So we discussed it earlier, how it does that. And then they create a USB object from the USB class, and then they pass a pointer to that class, or a reference, that should say, to their PS4 USB class, that is, to create the PS4 object. And then once they've got this object defined, they begin the serial interface, which is between the PC here and the Arduino via the Arduino's USB port. So we've already defined using tools that the port will be COM4 and for the PC. So the port COM4, we're going to talk to it using this. And in order to program the Arduino with this example code, it has to be compiled and downloaded. And this says upload, but it typically does a compile first and then it uploads. So we'll do that, and we'll check the output and see what happens. Okay, so it did the compile. And as you see over here, it's done uploading. So the Arduino Uno now has the example compiled and loaded. With the Arduino powered and operating right now, you see that the PS4 USB library started message has been displayed here on the serial monitor. And in this code, you can see right here that that happened during the setup, where it checked to make sure that it could talk to the controller chip on the USB host shield. So whatever may happen next, it's going to depend on if it sees a connection, as we discussed earlier, that the connecting device is going to make either the D+ or the D- communication lines change from the two states that it defaults to as long as something's not connected. That is, they're both being held high right now. So if one or the other changes, then it'll see a connection and this will become true. So if the PS4 connected is true, it's going to execute this code. So I didn't spend a lot of time understanding this. I just want to see if we're connected, and if we are connected, do we get data back? So I can't speak to whoever wrote this driver for the PS4, but so let's see. Let's just take a look and see what we get. I'm going to connect the PS4 now to the host shield. This is the PS4. Let me connect it. Okay, to the host shield. Here we go. Okay, now I've just connected it, and it appears we're getting a lot of data back. So apparently it saw the connection. So now connected is true, and it's going through and printing continuously data about the controller. Okay, I just picked the controller up, and so you can see the data. And I'll try to push some buttons. Oh, that just started the vibrator working. Let's try that again. You can see blips as the data goes by that something was detected. So it is working, and it is reporting data. So I'm going to disconnect it from the shield. So now the PS4 controller is disconnected, and you can scroll back through the data. You can see that it's going. The problem is it's running so fast that it's just overdriving the interface. Let me see if I can scroll back a little bit quicker so we can see some. There. I just saw some flash past. There we go. So here you can see that there was actual data being detected, and this X1 thing was being reported, where does that happen in the code? Well, like I say, I can't really speak to this code. I don't understand exactly what to expect, except that it does report data, and it did detect a connection. So that's exactly where we want to be. So the next thing I want to find out, since our USB shield is working just fine, is what happens when we connect it to an Arduino. And we're going to see if we can pass some data that way. Well, things don't always work out as I would desire them to, and oftentimes I learn more when that happens, and this may well be one of the outstanding cases of that. To use the host shield, I needed to create a driver that supports the NCE USB interface. To create a driver, I first needed to understand how I could use the Arduino USB host shield library as the interface software between my driver and the NCE USB interface. Well, I enjoy a challenge, but I way underestimated what this challenge was going to be. I wandered into this one without realizing that neither the library nor the Let Go host shield had any documentation anywhere. I've searched everywhere, and best I could find were examples where people show you that they can hook up a host shield. Well, I can hook up a host shield. I mean, that didn't tell me anything. And of course, in their instances, they generally work. But anyway, to enjoy the challenge, I would like to have some positive outcomes. This challenge is just ongoing right now. I hate to bring this kind of disappointment to everybody, but who knows how it's going to turn out, because I haven't given up yet. As I say, I enjoy a challenge, but I didn't realize neither the library nor the Let Go had any documentation. Now, I've studied the USB specification and the maxims MAX 3421E electrical specification and its programming guide. And I did a code walk through several examples that were supplied with the library. In particular, that the PS4 controller example that I originally had working. And I had, well, in total, I've spent several weeks putting this all together in my head. Now that I've begun building this, started building the prototype driver, I've got hit with yet another obstacle. And this is where the frustration comes in. It appears that the high let go host shield has stopped working. I'm not able to repeat the PS4 example. It just won't run. I've tried a number of different ways to try to understand that, but I'm still not able to get it to run. And I'm not hitting upon anything yet. The example will start correctly in that it does detect, it detects the 3421E component, on the host shield board, but that's the limit. It doesn't attach it doesn't detect anything as being attached. And so at this juncture of my project, I have 3 directions I can go. I can abandon the project, or I can buy a host shield, a second host shield, and hope that it works. And well, the final direction is that I can troubleshoot this current shield and see if I can get that to work. So anyway, I've decided on both of those last 2 choices. I've ordered a second shield, and while I wait, and it's going to be through Christmas now, we'll troubleshoot the one that I currently have. And I'll record my troubleshooting progress, and so I'll share that in a future episode, and I will also share what the result is with this next host shield. If I can get it working with that one, I'll be good again, and if not, it looks like there's limits to my patience, and this is testing that, but I haven't given up, and so we'll see how this all turns out in the next episode.